Hello, I'm Mackenzie, and I'm the Supervisor of Laboratory Education here at the Boonshoft Museum of Discovery. Today, we are in the Science Theater, powered by Dayton Power and Light. Do you like to watch movies where the characters are flying around in space, shooting at each other, and maybe blowing up a space station the size of a small moon? Well, today we are going to be learning about sound, and although they may sound cool to hear all of the explosions, it may not actually be possible to hear it. Sound is all around us, whether it is the birds chirping on a crisp spring morning or the smoke alarm going off because dinner is ready. Now, have you ever wondered why sound works the way it does? It's because sound is a form of energy, and energy comes in many different types. We have light, heat, magnetism, electricity, and many others. We cannot create or destroy energy. We can only change it from one type into another. So with my record player, I can take the electrical energy that's in the cord and turn it into sound. That happens because when we turn this on, the electrical energy moves to the motor, where we get magnetic energy to turn the motor, which is mechanical energy. That mechanical energy then turns into electrical energy with that needle, and that electrical energy goes to our speakers to produce some lovely music. Sound energy will move or propagate by making waves in the air molecules. If you think of air molecules as bumper cars, as one car bumps into another, energy is transferred, causing the cars to accelerate in a different direction. When the cars move together, they can move energy across a surface. Sound energy needs some form of media or material to move through in order to transfer the energy. This could be the air around us, the water in the ocean, or even the ground beneath our feet. Here we have a Rubens tube, invented by Heinrich Rubens as a way to visualize sound. Now, the way that this will work is that we can use these flames to show the sound. As I tap on the end, you'll see that the flames get higher because the sound, or the pressure waves moving through, will push more flammable gas out. If we put a static wave at the end, we can actually see the sound wave. A sound wave has two main parts. It has wavelength and amplitude. The wavelength is the length going from one peak to the next peak of a wave. The amplitude is the height of the wave. Now, with this wave, we can actually see higher points and lower points. And if I change our frequency, we can change the shape of the wave. The areas that have a lower part or a trough are going to be a lower part of our wave, where we have a higher point over here. So you can actually see the wave as it goes higher and lower. So we can actually put music through our Rubens tube. And as we do this, the notes in the song will create different patterns in our flame. This happens as the waves of these notes combine, and they end up making taller peaks or shorter troughs. So let's turn on a little bit of music and see what it looks like. So now we're going to find out what happens if we have sound in a vacuum. So for that, we've got our sound making device right here. It's a little music box, and if I turn our gear and let it run, we get a little bit of music from it. Now, to remove the media, to create our vacuum, we're going to use a vacuum chamber. I'm able to take out all of the air from here, and we're going to find out what happens with our sound. You'll notice there's already a flashlight in there, and that's to show that even in a vacuum, light can still travel through. It doesn't need a media. So I'm going to tape our music box to our lid. I'm going to place our lid on top of our container with our music box inside and turn on the vacuum pump. Now, we're removing all the air from this container, and what we're going to find out is what happens to our sound. Now, if we look at our container, we can see that the gears are still moving on our music box and our light is still on. This shows us our light is still able to go through. But if you listen really carefully, you'll notice there's no sound. And that is because sound cannot travel through a vacuum. It needs that media, it needs the air or something to travel through. This is why if you're watching a movie of people in space, you're not going to actually hear the sounds of lasers or of a space station exploding. We're not going to be able to hear these really cool sounds that we get in the movies. Now, if you liked this video, I do ask that you please hit that like button and you subscribe, and we will see you next time. Bye.